Welcome back. So this section is going to be the most important, at the same time most interesting, where we learn how to interact with Llama 2. So we'll focus on setting up the environment, like launching the text generation inference container, tweaking the model parameters, and launching the server, the text generation inference server. And then we'll take a deeper look at prompt engineering. Basically, what is the format that Llama expects us to send as the prompt template, number one. Number two, what are the prompt techniques that we can use to reduce what is called as hallucination and increase the accuracy of response. And then we'll understand what are tokens, which are fundamental building blocks of any large language model. And then there are parameters that will influence the accuracy and the response of the LLM. So they are typically sent via the inference server or the API server. In our case, this is the text generation inference servers from Hugging Face. So we are going to look at how do we tweak the API parameters to control the response or to influence the response from the LLM. So let's get started. So for the next few demos and labs, we need to set up the environment. So go ahead and launch a Vultr GPU stack instance and SSH into it based on the credentials that you see here. So we are within the instance. It's time to do a couple of things. The first step is to install the appropriate Python module. So I'm going to introduce you to what is called as the Hugging Face Hub. Now, this is a Python library to basically deal with the text generation inference text generation API. It's very handy. So we're going to install that. And then we'll also install the Python module called transformers that will help us deal with the tokens and deal with all things transformers. So this is a very important module that we are going to deal with. So we'll install that. Now, once that is done, the next step is obviously to launch the TGI, the Hugging Face Text Generation Inference Container. And for that, we need to initialize a couple of environment variables. So we will define the model, which is Llama 2 7 billion parameter. And then we are going to download the model into the data directory, which is already created. Refer to the previous lab on the steps involved. It is not very different. Of course, the token that you have created at Hugging Face, we initialize the environment variables. It's time to run the Docker run command. So I have already downloaded the model and everything is in place. So we can confirm that by running the logs. So Docker logs followed by the container name h of TGI. And it is getting ready. So we will give it a couple of minutes and we should see the message that the web server is listening on all IP addresses. Now, this is an indication that the text generation inference container is up and running based on the model, which is Llama 2 7B. So that's perfect. Now, the next step is to get the token associated with the pre-configured Jupyter Lab that's accessible at this location. Now, if you actually see, the token is available right here. Now, copy this and then switch to the browser window and launch the Jupyter Lab interface, which has the IP address and there we go. So the IP address and the token. So now we are able to access the environment, the Jupyter Notebook environment. So in the next lesson, we will take a closer look at how to craft the prompt. All right, so this is going to be interesting. Now, every large language model has a specific template or a format to interact with. Now, think of that as the grammar or the semantics involved in dealing with the LLM. Now, this varies from one LLM to another. For example, when you are dealing with OpenAI's GPT-4, the way you interact with, the way you craft the prompt is very different from the way you interact with Llama 2. So this is largely defined during the pre-training process, and following this would ensure that the responses are always predictable and accurate. So I'm going to walk you through the format or the ways of making sure that you are prompting Llama the right way to get the expected response. So the Hugging Face Llama 2 blog has a very important definition. So the prompt template is going to look something like this. So it starts with the S in angular brackets, and then the instruction, followed by the system prompt, and then the user message, and it finally ends with the instruction. So this template is what the Llama developers use during the pre-training. Now, if we follow this, we are ensured that we get accurate and predictable response. So how does this look like? Well, if you look at the way it actually turns out, so let me show you the three techniques or the formats used in prompting Llama. So the first one basically indicates the start of the prompt, which is also called as the start token. Now, this is not mandatory, but it's a good idea to include. Then there is something called as the system message. Now, the system message is used to create a kind of a persona for the LLM. You can also call this as the system role. So if you want the LLM to act as a physics teacher or as an expert in a certain field, you would actually put that here. So the system message will induce a kind of a personality into the LLM. So that is used in a lot of scenarios. Then there is an actual prompt, which is called the message. And then the LLM would come back to us with the response, and this is the end token, which will basically end the stream or inform the model that the generation is complete. So this is the typical format of dealing with Llama 2 model. Now, you can also ignore the system message. That's completely optional, but using that will have some kind of an influence on the LLM to behave in a specific form. But if you ignore that, you can only follow this format where you start with the token, and then you basically have the instruction, which is the user prompt and the user role, and then the LLM will come back with the answer. So these are the typical formats that we typically use in interacting with Llama 2. So let's see this in action. So for that, we will switch to the Jupyter Notebook environment, and then we will take a look at how we can use this programmatically. So I'm going to launch a new notebook. Let me zoom this a little bit. All right. So I'm going to now call this, let's say, prompt template. So I'm going to rename this with prompt template. Okay. So the first step is to import the inference client library. So you can ignore the warnings. That is totally fine. And then we have to initialize the client based on the URI. And this is the public IP address of the Vultr GPU stack instance. So we are now pointing the client to the TGI, which is the Hugging Face Text Generation Inference endpoint. So once that is done, let's go ahead and define the system role for the prompt. So here we basically use a multi-line string, So the role is, as I mentioned, is a mechanism to impart a certain persona or a personality to the LLM. So here you're saying you're a helpful, respectful, honest assistant. Ensure that your responses are socially unbiased and positive in nature. And if you don't know something, always say, I don't know, and don't share false information. Now, this role or this system message will certainly influence the LLM to avoid false responses or a process which is also called hallucination. So hallucination is LLM very confidently giving inaccurate responses. So by setting this, we influence and we control the hallucination, or we rather reduce the hallucination, because we are instructing the LLM to stick to factually correct and coherent response. And if it doesn't know what it is talking about, it should say, I don't know, but it shouldn't hallucinate. So after setting that, which was the system role, let's define the user prompt. So now my prompt is, there is a python in my garden, what should I do? So this is what I am asking the LLM, having set the persona in the previous cell. So then we will go ahead and construct the prompt. So now we have everything here. So if you look at this F string, we are crafting the entire prompt. So it starts with this token. This is a special token, which is indicating that it is the start of the prompt. And then we are adding the instruction. And within that, we are basically using the system role. And then we are sending the user prompt. So, and then we end the entire instruction. Okay. So that defines the prompt. Now let's go ahead and run the prompt. So this is exactly how it is being constructed before it is sent to the LLM. So now you can actually see all the placeholders are populated. It's very clear that we are setting up the persona through the system role, and then we are actually sending our prompt, which is, there is a python in my garden, what should I do? So the last step is to go ahead and invoke the endpoint, which will basically accept our prompt and comes back with the response. So we are dealing with 500 tokens. Now don't worry about this. I'm going to explain why we need to put this, what this parameter really means. So what I'm basically doing here is getting back the output from the model, remove all the unwanted spaces and print it. So let's go ahead and invoke this. So not bad. It's been pretty fast. So now if you actually look at the response, it says, thanks for reaching out. It's being very, very humble and very friendly. That's what we mentioned. Be a helpful, respectful, and honest assistant. So that's what is making the LLM to add this beginning line that says, thanks for reaching out. I'm here to help you with your concern. However, I must inform that it is not possible for a Python to be in your garden because they are not native to most gardens, which is very logical. But if you are concerned about a snake in your garden, recommend contacting a local wildlife expert, blah, 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 which is a pretty decent answer. And it also reminds us to be respectful to wildlife and act with caution. Now, it ends the entire response by saying, if you have further questions, feel free to ask. Now, this is very, very unlike the other responses that you typically see. And the reason why this LLM is behaving or responding in this way is all because of this specific role that we have defined. So the key takeaway from this demo is the importance of crafting your prompt in the right template or the right format. Of course, we are going to look at additional techniques, but irrespective of the technique, it's very important for you to follow this prompt template every time you're talking to Llama. So that's the key takeaway. In fact, as we explore other mechanisms like LangChain, we'll see how this plays a significant role in getting appropriate responses from Llama 2. So this was the demo where we have seen the right prompt template to use when dealing with Llama. So apart from crafting the prompt the right way, there are techniques for prompt engineering. So one of the first techniques is called the zero-shot prompting. So zero-shot prompting, as the name suggests, is a mechanism of prompting the LLM without any context or background and asking that to generate the response based on just a question or a request. It doesn't have any examples or precedents or context to look up to while generating the response. It is purely dependent on the ability of the LLM to generate the response, which translates to the ability to retrieve from the pre-trained data set on which it has been trained. So let's take a look at zero-shot prompting and how to use that with Llama 2. So we are going to use the same inference client from Hugging Face Hub. We are setting the URI of the client to the Vultr GPU stack public IP address. And then I have created a function here that's called chat completion, which accepts the system prompt, the user prompt, and the max length token. So the token length. Now, by default, I am initializing this to 100, but we'll explore this in the upcoming videos. But by default, it is set to 100. We can define that based on the prompt. Then we are setting up the system role as a helpful AI assistant, and we're also asking that to be concise in the response. So this is a mechanism to make sure that the LLM doesn't hallucinate or doesn't give us factually incorrect answers, and it's also very crisp in its responses. So we'll go ahead and define this system role, and then in zero-shot prompting, the user prompt will have no examples, no precedents set. Now, in this scenario, we are basically asking Llama 2 to imagine a data set showing a significant increase in online retail electronic sales over the past 3 years, particularly in mobile devices and wearable technology. Provide an analysis of this trend and potential reasons behind it. Now, it's a very involving prompt. We are throwing a complex task at the LLM, asking it to analyze why the sales of electronics, especially the wearables and mobile electronics, have gone up in the last 3 years. Now, let's initialize this and hit the endpoint and wait for the LLM to generate the response. Now, you see that I'm increasing the length to 1000 because I want a longer response. Now it comes back. It's pretty fast. So it comes back with the response and looks like it has done a decent job. So here is a concise analysis of the trend analysis. The dataset shows a significant increase with the compound annual growth of 15%. This is made up, but not bad. Mobile devices and wearable technology have been the driving force, with sales increasing by 20 and 30% respectively. And the results: the rise of smartphones and mobile devices, blah, blah, blah. COVID-19 has accelerated the shift to online shopping. Not bad at all. Now, it looks very convincing, and it comes back with a pretty comprehensive analysis and a very good structure. If you see, it has created the analysis and then even the reasons, exactly how we asked, and then it also summarized with a one-liner. Overall, the growth in online retail electronics is driven blah, 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 which is pretty decent. Now, let's try one more zero-shot prompting examples. So here we are actually asking Llama 2 to discuss the ethical implications of using AI in decision-making that directly affects human lives, employment, legal, and various other aspects like healthcare. Now again, this is a very involving, complex prompt, and we are completely letting LLM, which is Llama 2, to decide what are the ethical implications? So let's initialize this and invoke it. Now it's going to come back. And if you notice, I've set the prompt length, the token length 1500 because I want a slightly longer response. So it comes back, and again, it has numbered the points: bias and discrimination, lack of transparency, accountability, privacy, healthcare, autonomous weapons. So it has done a pretty good job of calling out some of the implications of using AI in the decision making that directly impacts human lives. So pretty decent. So this is called zero-shot prompt, where we directly pose a question without any examples or without any precedents. So in the next example, we'll see what is called one-shot prompting, where we will provide exactly one example to Llama 2 and let it infer from that example. So that is obviously is going to be called as one-shot prompting. So let's take a look at what is called as one-shot prompting, in which we provide an example and then let the LLM follow the instructions based on the example. So here everything remains the same. We are pointing the inference client to the URI, the endpoint, and then we are defining the chat completion function. And this is where it starts to get interesting. So the system prompt is now asking Llama to act as a language translator, specializing in translating text from English to French. Don't say anything else but the value. So that is a clear instruction, which is going to be sent as the system prompt. And then within the user prompt, there is a very specific instruction. Here is a sentence in English, and we enclose that in this identifier called EN, and then we provide an example, just one example, where we enclose the conversion or the translation in FR. Based on that, we are asking Llama to translate this sentence into French. So when we run this, look at how accurately Llama 2 comes back. And mind you, this is just the 7 billion parameter. It is not even the 13 billion parameter. So for a 7 billion parameter, this is pretty powerful and pretty impressive. So it comes back with the French translation, and it not only translates, but also follows the exact format that we have provided in the previous example. In the one example that we included in the user prompt, there is a format which the LLM is following. That is why it is called as the one-shot prompting technique. So similarly, we are now defining another persona for the LLM, and we are asking Llama 2 to act as a poet specializing in writing Japanese haikus. Be concise and respond only with the haiku, don't say anything else. So that is the system prompt. And then the user prompt is, here is an example of a haiku, a traditional form of Japanese poetry, and we provide a few lines. Now write a new haiku about the autumn season. That's it. Just one example. Now it comes back. Leaves fall, skies embrace. Sounds like a very authentic Japanese haiku. So this is a clear example, or a couple of examples of what is called as the one-shot prompting, where we provide exactly one example and ask the LLM to follow the rest. So it is a very powerful technique where you just give one example and let the LLM take that as the instruction and generate the response. So let's also take a look at few short prompts or few short prompt engineering technique in the next video. So following the examples of prompt engineering techniques, let's now take a closer look at what is called as the few shot prompting. So as you can imagine, few shot prompting is giving the LLM more than one example and expecting that to complete the remaining. So let's go ahead and run this notebook. So we'll import the module, point it to the Vultr GPU stack endpoint where we are running the Hugging Face text generation inference, define a function that accepts the input, crafts the prompt, and invokes the endpoint. And then we are setting a generic system prompt here because we don't need any specific persona. So we are just asking the LLM to act as a helpful AI assistant. And then if you look at the user prompt, this is where we define multiple examples. So there is one example that defines a fact or a phrase. So we expect the LLM to come back and finish the task where we have very similar format, the input, and then we expect the LLM to come back with the output. So let's run this. So we are now invoking the endpoint, and there we go. It comes back. The pen is mightier than the sword. So if you notice, it's pretty accurate in following the instructions. It has exactly formatted the output in the way we want. If you notice, we omitted output deliberately, but it came back with the output. And also, it added a period because the previous two examples ended with a period. So that's a classic example of how you can use few-shot prompting with Llama 2. Now let's take a slightly more complex mechanism or complex example. LLMs are believed to be not so good at doing arithmetic or math. But here, we are giving a slightly complex example. The first example is an addition. The second is a multiplication. And the third one, which we are asking the LLM to complete, is a subtraction task. So let's go ahead and run this. So we are setting the examples and then we are invoking. Not bad at all. So it has taken this as the input and came back exactly with the output, the way it is expected to be formatted. So this is an example of few short prompt engineering where you can pass multiple examples and there is something for the LLM to look up to and derive the next output or the response. So this completes an important topic about prompt engineering. So first we looked at the template to interact with Llama 2, which is this. Then leveraging that template, we looked at how to use various techniques to get what we want out of the LLM. So in the next video, we will take a closer look at what are called as tokens and why it is important for us to understand and factor the length of tokens in our prompts. Okay, so when we are learning about large language models, it's extremely important to understand a process called tokenization. So language models are essentially machine learning models. And as we know, machine learning models don't understand the text or characters or words. Instead, they rely on numbers. So we have to find a scheme to convert the text into numbers. That is the process which is called as tokenization. Now, if you recall, in one of my previous videos, I discussed tokens, vectors, and embeddings. So tokens are essentially a numerical representation of characters or words or sentences. And that is how large language models essentially comprehend what is being sent as an input, and also they generate tokens as output, which are going to be decoded into text. So you can think of tokenization as a process of converting your prompt into a set of numbers that the LLM can understand. And similarly, the LLM will send a set of tokens which are going to be decoded before we see that as text. Now, why is this relevant and why is this important? So this is important because we got to understand that every large language model has a specific context length. So the context length is the window which has an acceptable number of tokens as input. obviously you cannot send more number of tokens than what is expected by the LLM. And this is defined during the pre-training phase. So when we are crafting prompts and when we are expecting the output from an LLM, it's important for us to understand the length, the context length that is expected both as an input and what is coming out from the LLM. And we have to appropriately craft our prompt based on that. So to do that, we need to understand the length of the prompt that we are sending, and we need to understand tokenization. So that is the background on why tokenization is important. It basically gives us an opportunity to find out whether we are within the budget of the accepted context length of the given LLM. So Llama 2 has a context length of 4096 tokens. So whatever we do should be confined within that. And remember, this is the combination of both the input and the output. So whatever you send, which is as a prompt, and the context, which is an additional input that you provide, all of that should fit into the acceptable context length. So you cannot exceed that. That's the reason why we need to understand tokenization and calculate tokens as the parameters that are sent as an input parameter that is sent to the LLM. So let's explore the concept of tokens programmatically. Remember, we installed the transformers pip module. So let's go ahead and import the auto tokenizer. Now, auto tokenizer is a module that is going to take some input and generate the tokens based on the target model. So now what we're going to do is to basically point the model as the Llama 2 7 billion parameter model. This is what we have been using, which is running inside the TGI container. And we now pass that as the model ID and the Hugging Face token. So this is going to be very important because based on the LLM that you're using, you have to use the appropriate tokenizer. So you cannot use a different tokenizer targeting a different LLM. They need to be the same because ultimately the tokenizer will use the same format, schema, and the mechanism that's been used to train the LLM. So when you actually run this, it's going to take a while. It's going to download the tokenizer model. It's not as big as the LLM. It is a few megabytes. So now the tokenizer model is downloaded to our local environment. And now we can basically start converting text to tokens. So let's say we have a very simple prompt that says apple is a fruit. And we are now going to encode this by calling the tokenizer that we just configured. So the encoded value is going to look like this. So when you print the encoded value, it basically has input IDs and an attention mask. You can safely ignore the attention mask, that is not very relevant. So you can basically extract just the input IDs, and this is essentially the set of tokens that are representing the prompt. Now, to make sure that we understand the concept, let's use another prompt. So this time I'm actually using a different prompt, but let's encode this and also look at the input IDs. Now, they may be slightly different depending on the length, the number of characters, the words that you use. So now what we're going to do is compare the input IDs of this prompt versus this. So as you can see, the length of encoded value is slightly different. There are only 5 elements here, and here we actually see 6, but the last 3 are identical. That's because the sentence is mostly identical. The words are almost same. Is a fruit is kind of translating into these 3 elements of this vector, and we can see that they are the same. Now, if we use something completely different, for example, I'm going to now use a different prompt, or rather text, and look at the encoded value of that. Now, this is not going to match the previous two prompts in any ways because it's completely different. So what we are basically doing here is leveraging the same tokenizer that was used to train the model to convert a text or rather a collection of words into a set of tokens. So let's now take a look at more values. For example, let's compare what really is the difference between the number of words versus the number of tokens. So for that, we'll create a handy function called count words. Now that's going to take a sentence and returns the number of words in it. Pretty straightforward. And then we'll also find the length of the tokens that are generated from the same sentence. So let's copy paste and run this. So now here what we're actually doing is we are taking a sentence, the quick brown fox jumps over the lazy dog, and then we'll first print the number of words, and then we're going to tokenize the same prompt and look at the length of the encoded value. So interestingly, there is a slight difference, and this is expected because the point that I want to drive across is there is no one-on-one mapping between the word and the token. So behind the scenes, the tokenization process uses a mechanism that is very, very different. Each model might use a different mechanism. So that translates to a different set of values. For example, here, 9 words have been translated to 12 tokens. So that is how the tokenization or the tokenizer was designed to be. Now, what is important is, as I mentioned earlier, the Llama 2 model is trained to accept the maximum number of tokens as 4096. Now, it's a good idea and a best practice to basically make sure that your prompt is less than 4096, not just the prompt. You also need to leave room for the output. So if you are expecting 3000 tokens to come out of the prompt, then you have to leave enough room. That means your context plus prompt plus everything that you send should be roughly about 1000 tokens. And that will leave enough room for the LLM to generate 4000 or remaining 3000 plus tokens, which will be a lengthy output. So you need to factor that. And that's the reason why we are discussing the concept of tokenization and the idea of measuring the token size before we invoke the model. So having understood tokens, let's take a look at some of the parameters that influence the response from LLM. So when you're launching the Hugging Face text generation inference container, make sure you include 2 parameters that are essential for controlling how many tokens are generated and even how many tokens are accepted. So the first parameter is the max input length. Now, this is going to define what is the length of tokens that you can send as an input through the prompt. Max total tokens is what is that the LLM is enabled to generate, including the prompt plus the output that is a part of the generation. So these two are very important if you want to go beyond the defaults. The default is, I think, 1024. That is the max total token. So you will see an error if you don't change this parameter when you're launching the Docker container. So make sure you are using these parameters when you are enabling the model and you're exposing that through the Hugging Face TGI, which is the text generation inference container. Okay, so now that we have expanded the Docker container limits to accept additional tokens for input and text generation, let's see how we can leverage some of the parameters that can influence the output. So you see something very familiar here. So we are importing the inference client, pointing that to the public IP of the virtual GPU stack instance, and then I am defining the chat completion function. But what you see here is a set of new parameters. We briefly touched on length in the previous videos, but I haven't discussed things like temperature, repetition penalty, top P, and top K, which is the focus of this demo. So what we'll do is we will take a closer look at each of these parameters and see how they actually influence the outcome, the output of the LLM. So we defined this function and we left the defaults. So we are going to use Llama 2 as a storyteller. So it's going to be creative. It's going to take a one-shot prompting example of starting the short story with a specific phrase and then using that as an example to generate another short story. So the system prompt is, you're an assistant to help me write short stories. And this means we don't need factual, coherent details, but it can be creative. So we are not asking about historical facts or mathematical, logical reasoning problems. Rather, we want the LLM to be very creative. So there is a system prompt, and then the user prompt is, there is an opening of a fairy tale, which goes something like this: once upon a time, in a kingdom far, far away, blah, blah, blah. And then we are asking Llama 2 to write a new fairy tale that starts with something like, in a land filled with whispers and magic, there was a peculiar rabbit known to all. Now it has to go ahead and complete the short story, which has this beginning. So it's pretty creative. So now initially, what we'll do is we'll not use any parameters and we'll go by the defaults. So we are simply sending the system prompt, which is, you're an assistant to help me write short stories, and then the user prompt. So when we actually run this, we'll get some output, but it is very obvious that it's incomplete. Now, it's cut off. In a land filled with whispers and magic, it starts as instructed, and then it goes to the next para and gets cut off. That's because we haven't used a parameter, which is the length. Now, this length will define the max new tokens, which will define how many new tokens can the model generate. Now, since we didn't really give anything, I think it used 100, which is the default, and that's the reason why we see an abrupt ending to the story. Now, what we'll do is, in the next invocation, we will use the max new tokens parameter by sending the length. So length is used for max new tokens. Now, if you look at the documentation of text generation on Hugging Face website, you actually see max new tokens is the maximum number of generated tokens. And if you look at somewhere here, it is just 20. It's not even 100. It's just fairly low. So what we'll do is, now we'll increase that to 1500, which is pretty large, and which will translate to a decent chunk of a short story. So let's go ahead and run this. The idea is to increase the max new tokens and generate. And now it doesn't abruptly end. It comes back with more complete response. So how does it sound? Do you have any ideas? And it is actually fairly creative, and it is also asking us for a follow-up, with any new ideas. So that's great. So the takeaway from this method is the new parameter that we included, which is the length, which translates to max new tokens. So that is one. And obviously, max new tokens cannot exceed the length of the model size, the model size parameters and the acceptable context length. And also, if you remember, when we launched the container, we actually used these parameters, max input length, which is defaulting to 1024. And we also have the other parameters like the max total tokens. So by default, it is 2048. Now, obviously, if you have left this to defaults, you cannot really go beyond that. So it's important to tweak the parameters used with the text generation interface container, text generation inference container, and stay within the limits when you are invoking it from the API. So they are correlated. All right, now coming back, I want to introduce one more parameter to our invocation for the text generation. And this time, we will leave length as 1500, but we are going to play with a parameter that's actually called the temperature. Now, temperature is a very powerful parameter. And currently, temperature is set to none. By default, temperature is always set to none. If you look at the documentation, it is always set to none. But when you actually use this, it can be anywhere between 0 and a large number. So this will basically define how creative is the output going to be. So let's start with 0.2. Now, 0.2 doesn't make the LLM very creative. It basically restricts the LLM to come out with highly predictable, highly constrained response. So we'll go ahead and run this. Now, this is very similar to what we have seen previously. In fact, it is almost word-to-word copy of the previous response, right? So it's very, very similar with very subtle changes. Now, how can we make the LLM more creative? Well, let's go from 0.5 to, let's say, 0.8. That's a huge leap. And what this basically means is we are giving more room for the LLM to act creative. So now this is going to take slightly longer because the LLM will have to work. And now it comes back with a slightly more creative response. Now it is actually calling the rabbit as moon whisker, and it is weaving a story around that. Now, if you increase this further, for example, let's go from 0.8 to 1.5 and run this. Now, this will make it further creative. It might even generate longer responses because we are asking it to be very creative. And this is taking much longer than the previous responses because temperature 1.5 is pretty large room for the LLM to play with the output tokens and being very creative. Now, if you actually see, it not only generated a long response, but it is pretty irrelevant and it is garbage. It doesn't really make sense. It generated some random text. So what it basically means is as you increase the temperature, you are letting the LLM use more random output or randomization of the tokens. And that's the reason why you see very, very coherent, random, almost garbled up content. Now, if you come back and make this 1 and execute, it stays within its limit, but it is still creative. So that's the reason why you have to be very careful the way you use temperature parameter. Now, when you're doing arithmetic, when you're doing reasoning, when you're doing analysis, you should keep the temperature to minimum. For example, something like 0.1. Now, this forces the LLM to stick to the facts and doesn't give enough room to be creative. So that's the reason why when you're dealing with reasoning and logic related prompts, it's better to use the lowest value for the temperature. And when you are dealing with creative prompts, it's okay to increase the number, but don't go too far. As we have seen previously, this will generate very random, almost meaningless garbage output. So not worth it. So you have to play with the temperature parameter to make sure you are hitting the sweet spot, because there is no magic number. It depends on the prompt and depends on the output, and you have to tune it and tweak it till you get to a point where it is making sense. All right. So now let's move to another parameter called repetition penalty. So repetition penalty is basically penalizing the model for repeating itself. You would have seen in some models, the output repeats itself constantly and it doesn't add any value, it doesn't make any sense, and you'll see very repetitive words in the output. Now, how do you control that? By using this parameter called repetition penalty. Now, we are not using any other parameter. We are leaving everything else to default, and we are now sticking to repetition penalty, and we are setting this to 2, which means it will force the LLM to come out with unique values. It doesn't repeat itself. Now, every time it tries to repeat, the penalty is applied and it will force the next token to be picked up, which will translate to a different word. That's the reason why as you increase the repetition penalty, you'll see more and more unique words. So a combination of temperature, a higher value of temperature and repetition penalty will force the LLM to stick to its limit, to stick to the boundary, but still be creative. So that's an important parameter called the repetition penalty. Now, the other thing, the other parameter that I want to introduce is called the top P. So top P is also called as the nucleus sampling. Now, this is very, very similar to using temperature. In fact, you shouldn't be using both. Either you should use the temperature parameter or you should use the top P, because both of them have a very similar output. So top P or nucleus sampling limits the selection of tokens to a subset of vocabulary. Now, it helps in controlling the diversity of generated output, which is very similar to what temperature parameter does. So let's leave everything as is with defaults and then use the top P as 0.2. Now, this has the same impact as temperature. Now, you see it is getting slightly creative. It's calling the rabbit as master of shadows and so on. Now, you can increase the top P and you'll see different values. So basically, increasing the top P will expand the ability for the LLM to be more creative, because you are, again, dragging the slider towards more creativity and adding more words. So that's the reason why you should either use temperature or top P, but not both, because they influence exactly the same aspect of an LLM, which is creativity. And finally, one parameter that I want to touch upon is top K. So top K sampling is basically a technique that constrains the next token selection to the top K most likely tokens at each step. Again, it helps the LLM to be more diverse and controls the randomness. Again, this is like the previous parameters, but it basically enables the LLM to choose the most appropriate next token or the next word based on the value of top K. So top K sampling will make sure that the LLM picks the most obvious word in the choices it has. So again, let's start with 1 and see how it comes back. So basically, top K value, will help the LLM to pick the most obvious next token.